All right, guys, so we're going to continue on with the review sheet today. I think we got through finding the given information, the vertex, focus, axis of symmetry from the equation given, where the vertex was not 0, 0. Yeah. Yes, okay. Yep, so find the quadratic, or find the equation from the given information. So we're looking at these here. Now with these here, we still need to find the quadratic, our parabola. Now, we still need to find the values of h, k, and p to be able to find the equation. H, k, and p. Now the vertex is the point h, comma, k. So it tells us our h value is 7, and our k value is 3. Now, if it gave us the directrix as our other piece of information, it determines which equation a little bit easier, because one of them is going to be x equals h minus p, the other is y equals k minus p. It kind of gives us a direct answer for which one we have. But when we're given the focus, we're trying to see which spot changes and which one doesn't. And if we look at the focus, the 3 is the same. So it's saying the y value is just k. Now the x value, our h, for the vertex spot is 7, and it changes to 14. We added something to it, which would be our h plus p. We're trying to see which one changed. Which spot changed in the focus from the vertex? Did the first spot change? From 7 to 14, it did. Our other spot went from 3 to 3. It didn't change. So that tells us two things. One, that h plus 3, h plus p, not 3, h plus p, whatever the h value added to the p value, will give us a value of 14. It also told us that the general form of the equation is x equals 1 over 4p times y minus k squared plus h. And again, I would be referencing back to the information, our study guide for these here, and making sure they do match up, that we are using the correct equations. Now, for our equation itself, we've found 2/3 of our answers that we need. We found the value of h, we found the value of k. Now we just need to find the value of p. And we can use our h plus p equals 14. H in our case is 7. So we're saying 7 plus p is 14. We need to solve for the value of p. So we can subtract 7 from both sides, which tells us p is equal to. Now we just need to plug the information in. So we say x is equal to 1 over 4 times 7, our value p, parentheses y minus 3. Now there is one piece of information, or one spot, that we do need to simplify for this here. That's our 1 over 4 times 7, which would be 1 over 28 times y minus 3 squared plus 7. The only simplifying we would do inside the parentheses or after it is if we had a negative negative, or outside the parentheses we had plus and negative. We would need to fix those, because our minusing a negative would change to plus, and our plus and negative would change to minus. We're just sign changes. Any questions on number 24? Questions on 25 or 26? Let's look at 26. H, K, and P. Well, the vertex is given to us. It's our H, comma, K. So it's telling us the value of H is -6, and the value of k is -4. So at this point here, we still need to figure out the value of p and which general equation we need. Right. The y location's changing, our k value is changing. Because h is -6, it's still -6 in the focus, so it's still our h. The k value in the vertex is 4. Now that similar spot is -10. We added something to it, which is our k plus p. So this tells us two things. One, that the value of k plus p is -10. Whatever the value of p is added to our k value gives us -10. So we get y equals 1/4p times x minus h squared plus k, because that's the equation that corresponds to our h plus, comma k plus p. Questions on this here? And I know it might sound odd that we're saying that we added something to -4 to get to -10, because it feels like we should be subtracting, yes. But it's the same thing. We're just adding a negative to it. Questions on this here? Now, we can solve k plus p equals -10, because our value of k is -4. Now at this point here, we can add 4 to both sides, telling us p is -6. Yeah. It's not always going to be that way, because I think if you remember from 232, h, k, and p differed. And it's not always the case that h and k have to be numbers other than 0. One of them could be 0. We did have one of those on the homework. X minus -6 squared plus -4. Now I plugged it in as -6 and -4. Now, you could have gone on and simplified it, these two pieces here to begin with. You don't have to write it out as x minus -6, because this is the same as saying what? X squared minus 4. Our first one, 1/4 times -6, is -1/24. And that there's our equation. Questions on any of this here? Questions on anything we've done so far? Questions on 28 through 33? Yes. So we'll do one of 28 or 29. I'll let y'all pick which one. 28. Now this 28 and 29, or 28 through 30, whatever, because I can't remember 28, 29, 30, 31. 28 through 31? No. 33. Thank you. Are going to be in one of two forms. They're either going to be in x-intercept or vertex form. Now, one of the main ways that we know we're not using our y equals 1/4p or x equals 1/4p is because they gave us one of two things. Here they gave us the vertex and a point. Yes, they did not give us the directrix or the focus. So we're not using either one of those. So, since we are given the vertex, we're using our vertex form, y equals a times x minus h squared plus k. Now the vertex is still the point h comma k. Now we can plug that in. -6 for h, -12 for k. Inside our parentheses, our minus and negative is the same as plus. And our plus negative 12, we can say is just minus 12. Questions on this here so far? We feel good with getting to this point. Even if this is as far as you get, especially on the test, you get stuck, this here is 75% of the answer, 2/3 of the answer. Because the only thing we're missing in this is the value of A. Okay, you get the points for having the H and K values correct and doing the problem. You're just going to lose a point for A if you left it as this point here. So I would say at least get to this point even if you do get stuck. Now to find the value of A, we use the point it passes through to find the value of A. We plug the Y value in for Y, so negative 24 in for Y, is equal to A times our X value, so 0 plus 6 squared minus 12. Because what this is saying, whatever the value of A is, when I plug that X value as 0 in and simplify the entire right side, I should get a value of negative 24 with whatever the value of A is. So if I plug that X and Y value in, I can solve for the value of A. Now we can do 0 plus 6, which is 6 squared. Now 6 squared is 36. It's still being multiplied by A, so we'd have 36A. Do be careful on these here, because if that number inside the parentheses is negative and you type it in the calculator, you still need those parentheses, especially when typing it in the calculator. So if it was negative 2, you need a parentheses negative 2 close parentheses squared. If you don't include those parentheses, it does not see it as negative 2 times negative 2. It sees it as negative 2 times 2. It won't multiply that negative. It doesn't consider them connected with each other. If you're not sure, especially with an exponent, if you need the parentheses or not, go on and put them anyways. Because if they're not necessary, it's not going to cause an issue. But if they are necessary and you forget them, it's going to cause an issue. Now the next thing we can do is get the 36A by itself. So we can add 12 to both sides, telling us 36A is equal to, and last but not least, we would So the last thing we do is plug it back in. For this problem here, preferably, I want this as a fraction, not as a decimal. Because negative 1/3 as a decimal is negative 0.3, and then we just have 3 extended out indefinitely. If it's a repeated decimal, go on and leave it as a fraction. If the calculator does give it to you as a decimal, the button right above enter on the 30XS, the arrows going in either direction will convert it back to a fraction for you. If it doesn't, give me 4 spots, or you can ask. I will tell you how to go from there. Questions on this problem here? 29 is the exact same thing, because it gives us the vertex and a point. 30 is different because it does not give us the vertex and a point. It gives us the x-intercepts and a point. So that kind of tells us we're starting off in x-intercept form. Now the placement of P and Q, where P is and Q is interchangeable. We just need to know that P and Q for this formula here represents the x-intercepts. Negative 16, 0 and negative 2, 0 are also considered the x-intercepts. It's an x-intercept if the value of y is 0. But it also tells us the values of P and Q are negative 16 and negative 2. Now in both cases, we do have a negative negative. So both of these are going to be plus, positive. Now if you notice on this one here, just like the last one, the only thing we're missing is Hey, we've got 75% of the points just by getting this far. So the last thing we need to do is find the value of a. We'll plug 72 in for y, because that's our y value of the point it goes through, times a times negative 18 plus 16 times negative 18 plus 2. Now we can simplify both parentheses, so we'd have negative 2 and negative 16. Because we can do negative 18 plus 2 is negative 16. Negative 18 plus 16 is negative 2. Now we need to multiply these together. So whatever number we get, we will have an a value with it. So we're multiplying negative 2 times negative 16, which is 32. Two and a quarter. Yeah. At most 2. I feel like this is 9/4. 9/4. Yep. Well, which is 2.25. Now this one here, 9/4, or, bless you, 2.25. Either one of those will work, because 2.25 as a decimal is a nice, I would quote unquote nice decimal, because it has a definite endpoint and we're not having to round or do any of those kind of calculations. Or the last one where we had 0.3 repeated indefinitely, that's not a nice one to leave as a decimal in an equation, if that makes sense. Questions on any of these here? So I think we feel good with these here. Any questions on anything we've done so far? Okay, well that's it. No, I added those to this review sheet, but I decided not to put them on the test. So the first 5, I can go back over those. Those are bonus. So I know, Grace, I printed you a review sheet. Jordan ended up not getting it. 2, I think your number 4 and number 5 are different from what everybody else had, because I made an adjustment. We'll look at it first. So number 4, because I think most of y'all, if you did look at this here, the negative 4 would indeed be down 4. The 6 out front would indeed be a vertical stretch of 6. The negative in front of the parentheses would be a reflection across the y-axis. And our plus 3, what does it feel like we're doing? Would be to the where? Left or right? Right. Now, I'm going to pull up the graphing calculator for this here. Y equals. Clear that out. X. Clear that out. Zoom. Standard. Okay. No wonder. Because we're talking about a quadratic function. So this is our U-shaped graph, yes? So it should be down. So we should move it down stretch it so it should be a little bit narrower, reflect it across the x-axis, and then move 3 units to the left, yes? Okay. Y equals 6 parentheses negative x plus 3 close parentheses squared minus 4. Graph. It is narrower. It did move down. It moved to the right, yes? And the reason that it did that, that's why this is somewhat tricky, is because of this reflection across the y-axis. It did move left 3, but if we reflect it across the y-axis, it flips across that y-axis. So what we could think of it as negative x minus 3. And the way I rewrote that is I factored that negative out. I pulled it out, which turned the x value from negative to positive, but it also turned the 3 from being positive to, so we get this here. And if we think of it as the opposite, well, that's still our reflection across the y. X minus 3 is still the opposite of what we think, so it's moving to the right. I don't normally cover this because on the ones, I did adjust this on those, so I pulled that negative out because it does have a funky effect to it with this horizontal shrink, because without this here, we would not have that, and it would indeed be left 3, because without that reflection, because if I take that away, it does indeed move to the left 3. Y'all kind of see that? It's just when it's reflected across the y-axis, it flips it, which makes it look like it's moving right instead of left, and it's a little funky. Does that make sense? Yeah. That's kind of part of the reason I took, there wasn't one like those. But if we look at number 1, our plus 3 on the end is up 3. Our minus 1 inside is right 1. And the 1/2 in front is a vertical shrink of 1/2. Yeah. Yeah, they're funky. Especially with the reflection across the y-axis, because technically, if we said that it moved left 3 before we said it reflected, then it would work, because it's moved to the left 3 and then reflected across the y-axis. But again, these are purely bonus on the test, and I would do them last. Do the rest of the test first, and then if you do have time, come back to those, because they are worth 1 point apiece. So on number 1, if you gave me, if this was one of the ones on the test, you gave me up 3, right 1, and vertical shrink of 1/2, you would get the full point. You get the point. If you just gave me up 3 and right 1, no, I need all of it. It's going to be all or nothing on those. Yeah. So those on the test are all or nothing. If you do get it correct, you need all of it, but they're bonus. They're 1 point. Focus on the rest of it, because that's part of the reason I'm doing it, telling y'all focus on the rest of the test. Do not focus on those. If you do have time, go to them. If not,